Hi guys, my name is Elvis. You are welcome to my lessons today. Today we'll be talking about the periodic table in chemistry. So what is periodic table? Periodic table simply means the arrangement of elements according to their increasing atomic number. So you should know that there are 118 elements in this world. The total elements in the world there are 118 in number. But 90 out of these 118 elements are natural, like they occur naturally, while the remaining 28 elements are artificially being prepared in the laboratory. So you should know that periodic table simply means the arrangement of elements, how these elements are being arranged according to their increasing atomic numbers. So the story of periodic table actually began with Lavoisier, who actually classified elements according to metals and non-metals. And using this arrangement, some elements cannot fit in properly. Some elements which are called metalloids, they cannot fit into this particular arrangement because Lavoisier actually classified elements according to metals and non-metals. So it was within the year of 1869, between 1869 and 1871. It was Mitri Mendeleev who actually made the first periodic law. The law stated that the properties of an element varied periodically with their relative atomic masses. So to cut the whole story short, Mendeleev actually classified elements according to their increased atomic mass numbers, but what we are using today, the modern periodic table, elements are actually classified according to their increasing atomic numbers. So what is an atomic number? Atomic number simply means the number of electrons or the number of protons which are found in a given atom of an element. Elements are actually arranged in groups and in periods. So we actually have 8 groups from group 1 onto the 8th group. Then we actually have 7 periods. So for easy understanding, we use vertical lines to represent groups. So we have group 1, group 2, they are arranged in vertical lines. Then when you count the periods, we use the horizontal lines. So quickly, I like to add this also. Elements which are found in the same group have the same number of valence electrons. For example, like lithium, sodium, potassium, francium, calcium, they are found in the same group as group 1. Therefore, they have just one valence electron. So elements which are found in the same group, they have the same number of valence electrons. Group 1 elements have 1 valence electron. Group 2 elements have 2 valence electrons. Group 3 elements have 3 valence electrons. So elements which are found in the same group, they have the same valence electron. Why elements which are found in the same periods, they have the same number of shells. When you are doing electronic configuration, you discover that elements which are found in the same periods, they have the same number of shells. So quickly, the group 1 elements, they are called the alkalis. The alkali metals, they include the lithium, the sodium, the potassium, the rubidium, the calcium, the francium. Group 1 elements, they are known as alkali metals. Why are they called alkali metals? They react vigorously with cold water in order to liberate hydrogen gas and then form alkalis. So the alkali metals are known as group 1 elements. They ionize readily by donating their valence electron. They are actually known as reducing agents because oxidation takes place within these elements. Therefore, they are reducing agents. So group 1 elements are called the alkali metals. Group 2 elements are such as beryllium and barium, magnesium, calcium, so on and so forth. They are known as earth alkaline metals. They have 2 valence electrons. Remember, I told you elements which are found in the same group, they have the same number of valence electrons. So group 2 elements, they actually have 2 valence electrons. And they ionize by donating their 2 valence electrons, and as such, they are reducing agents because oxidation also takes place within these elements. So they are also reducing agents. Now, these group 2 elements are called earth alkaline metals. I've given an example like beryllium, magnesium, barium, calcium, so on and so forth. They are reducing agents. They are divalent. Why are they divalent? Because they have 2 valence electrons. So they are also reducing agents. So it has to be noted that in between the group 2 and the group 3 elements lies 10 set of elements. Like when you check the periodic table, you see there are actually 10 in number. We call them the transition elements. Yeah, so the group 3 elements actually they don't have a specific name, something like boron and aluminium. We have gallium, indium, and thallium, so on and so forth, the group 3 elements. Now, what are they? They are trivalent, meaning that they have 3 valence electrons. And they are also donors because they donate their 3 valence electrons, and as such, because they donate, they are actually reducing agents. So when we go to the group 4 elements, they also do not have a specific name. Something like tin, lead, carbon. These elements, they are tetravalent. Why did we say they are tetravalent? Because they have 4 valence electrons. So these elements are found in this group called the group 4. They exhibit what we call two oxidation states, and that is +2 and +4. So these elements, the group 4 element, they are actually tetravalent, meaning that the number of valence electrons they have is actually 4. And also the group 4 elements, they form what we call the covalent bonds. They don't form ionic bonds. They form what we call the covalent bonds. And also it has to be noted that carbon do not, or it doesn't react with water in any form. Carbon doesn't do that. So also we have the group 5 elements like oxygen and sulfur, so on and so forth. But you should know that the group 5 elements are also recipients. They are electron recipients. They receive electrons, and they do not attack water in any form, because oxygen, sulfur, they react in order to form water and others. So they do not attack water in any form. So we have the group 5 elements. Then we have the group 6 elements. We have the group 7 elements. Actually, the group 7 elements are called the halogens. The halogens are like iodine, chlorine, fluorine, so on. They are known as the halogens, the group 7 elements. And they are the most reactive non-metals. The halogens, they are very reactive, but they are not metals. They are not metals, therefore they are non-metals. Now, when finally we have the group O, or actually call them the group 8. They are known as noble gases, or rare gases, or inert gases. They are inert in nature, or something like a krypton, a xenon, something like argon, so on and so forth. They're known as the group 8 elements. These are some families in the periodic table, like the 8 groups in the periodic table, and the periods also. We have the groups and we have the periods. So like I have to practicalize something here before we go. You know what I said, elements which are found in the same group, they have the same number of valence electrons, and elements which are found in the same period, they have the same number of shells. So we are going to practically do that here before we go. Right, quickly, in order to demonstrate that elements which are found in the same group, they have the same number of valence electrons. So this is lithium, and this is sodium, and this is potassium. These 3 elements are found in the group 1, the group 1. So they are alkali metals. So let us do it now in order to ensure that they have the same number of valence electrons. So we are going to do electronic configuration using what we call the shells K, M, N, so on shells. You should know that K can only contains 2 electrons, L can contain 8, M can contain 8, and also N can contain 8 electrons. So these are known as the shells. So let's do an electronic configuration of sodium using this, using the KMN shells. So the lithium is actually having an atomic number which is 3 and mass number which is 6. So in electronic configuration, we use the atomic number and not the mass number. So for sodium here now, we are going to use 11 instead of 23. Then for potassium here, we're going to use 19 instead of 39. So let's do electronic configuration of sodium. Lithium, first of all, the atomic number for lithium is 3. So it simply means that for lithium here, K is equal, the K can only contains 2 electrons. So out of these 3, we write 2. And it is remaining 1 more electron to make it 3. So K has already taken 2 electrons. Then L, which can contain 8, but it is remaining 1 electron here because we've given K 2, and it's remaining 1 electron in this so we write it 1 here. So the number of shells which can be found at the outermost shell of an atom of a given element is what we call the electronic the valence electron. So we call it the valence electron. So the valence electron for lithium here is actually 1. Now let us do the one of sodium. Sodium is actually 1123. So like I said before, we are going to use the atomic number here. So for sodium now, for sodium K, which can take 2 electrons, we take 2 out of the 11, remaining 9. And we go for the M, which can contain only 8 electrons. So we write the 8. 8 plus 2 will give us 10, remaining 1 to make it 11. So we go for the third shell, which is actually M shell, and it is remaining 1, so we put it. So we have 8, 9, 10, 11 to get this guy. So what is the number? What is the valence electron here? Is actually 1. So you see that lithium and sodium are having the same valence electron. Finally, let's do the one of potassium. Potassium is actually like this. It's actually 19 and 39. So like I said before, we also use atomic number. So K is going to take only 2 electrons as usual, because here it can take 2. Then L is going to take 8 to make it 10, but we are looking for 19 because the atomic number for potassium is actually 19. So L will take 8 and remaining, this is to get 10, remaining 9. So you go for the third electron, the third shell, which is M shell, which can also take 8. So 8 plus 8 is going to give you 16, plus this is going to give you 18, remaining one more electron to get to 19. So you go for the N shell, which can take 1. So you cannot believe with me that lithium, sodium, and potassium, which are found in the same group as group 1 family, they are having the same number of valence electrons, that is 111. So elements which are found in the same group, if you continue to do it, you see that other elements which are associated with the group 1 element, they have the same number of valence electrons, which is 1. So that is why we said that they are monovalent. That means they have just one valence electron. So for you, if you want to do that, the one of group 2 is that they'll be having 2 valence electrons. Group 3 will be having 3 valence electrons. Like I said before, my name is Elvis. I'll meet you in our next video. See you.